So here we've got some fun. This time we've got two particles being projected, one shortly after the other. Let's see how we can cope with that situation. So there's the question, and let's start as normal by drawing a little diagram to help us. So we've got P being projected at 70 degrees and Q a little bit later at 40 degrees, the speed of 42. So what we're looking for is looking to see if the particles collide. So if we take the point at which they collide and say, well, if they did collide, and we said that they collided at time t seconds after P is projected, then at the point that they collide, they must have the same horizontal distance. So the x coordinate of P, the x displacement of P horizontally equals the displacement of Q horizontally. So let's look at the horizontal movement. So the horizontal displacement of particle P is its initial velocity, 25 cos 70, multiplied by the time between the time it's in motion up until the point that they collide. But xq, the horizontal displacement of q, we've got 42 cos 40 as its initial velocity, but it's being projected half a second later. So the time that it's in flight for is a half a second less than particle P. So the horizontal displacement of Q is its initial velocity multiplied by t minus 0.5. Now when we solve that equation, we get a t of that number. And I'm being retaining quite a lot of accuracy there. Okay, so the question is, do they collide? Well, they would only collide. We know that that is the time when their horizontal displacements are equal. We need to find out whether at that time their vertical displacements are equal as well. So if we look at particle P vertically, and we call its vertical displacement yp at this time 1.4685 that it's been in motion. If we take the upward direction as the positive direction, then the acceleration is minus 9.8. We're not interested in the final velocity. The initial velocity is 25 sine 70. For Q, it's very similar, except the time that Q has been in motion is half a second less than P. So its time at the point of collision would be 0.9685. So I need the formula, which doesn't have V in it, so that's S equals UT plus half AT squared, and I can use that formula for both of them. So the vertical displacement of particle P at that moment, where their horizontal displacements are the same, is this number. The vertical displacement of Q is that number, and they're quite close, aren't they? But not close enough to collide. So when the horizontal displacements are the same, the vertical displacements are different, and so the particles do not collide. Okay, so let's have a look at the next part of the question. So if the particles collide, well, we're not interested in that because we know they don't collide. If they don't collide, we've got to find the difference between their ranges, assuming they travel over horizontal ground. So if we look at P first and find the range of P, then we're looking to find what the horizontal displacement is when the vertical displacement is 0. So if we look at the vertical motion, taking the upward direction as positive, we're trying to find the time that P has been in motion when its vertical displacement is 0. So its initial vertical velocity is 25 sine 70 and acceleration due to gravity is minus 9.8 as before. And using S equals ut plus half at squared, we get this equation, which has got two answers. Tp equals 0, but that's not our point of interest. We're interested in where it returns to the ground, and that is when Tp is 4.7944, when P has been in motion for that length of time. So we can work out its range by multiplying its horizontal velocity by that time. So this horizontal velocity is 25 cos 70 multiplied by that time gives us a range for P of 40.99. If we look at Q now, then at the point where Q hits the ground, its vertical displacement will now be 0 again. Horizontal velocity of that, and we're calling that the time that Q has been in motion when it hits the ground, TQ. So S equals ut plus half at squared again, and that gives us this value, this equation, which gives us TQ as 5.5096. Now, the difference in their launch times is not relevant here because we're just looking to find the difference between their ranges. So the difference of half a second doesn't make any difference to these calculations. We can work out the range of Q by multiplying it by multiplying that time by the initial velocity horizontally, and then we can work out the difference in the ranges. That's the difference between these two numbers, 40.99 and 177.27. So the difference in their ranges is 136 meters. So there we are.